freaking nothing works. Nothing works. Don't know why the camera didn't work. Now it works. This is why I do this on the other channel. So I don't have to do this when I'm doing my videos for navigating patterns. I had a conversation a number of weeks ago now because I was in the hospital over Thanksgiving. Don't get kidney infection. That's the number one rule. So I haven't been recording anything, but I've been thinking about this conversation I had for weeks. I wanted to do a video on it. So we were talking about a bunch of things, but one of the things we were talking about was version control. Now, version control is a very simple, straightforward thing to do in computers. In the early days, I didn't use version control for code. That was pointless exercise. Back in the day for the coding I was doing, I might still make the argument don't use version control for various reasons. Maybe I'll get into that later. I don't know. But version control, I used to use it for documentation so that you could link the version of the documentation to the version of the release, because that's what was important. Now, I'm a release engineer. Version control is very useful for release. I use version control and release all the time. If I'm doing a private project, I don't have a release strategy most times, although I'm going to maybe develop an AI tool because something occurred to me that'd be really cool with version control and AI. Not around workflow the way you think, but around workflow. The ability to do version control, whatever, there's an evolution. We went from VCS to RCS to, more sophisticated systems, right? Like Mercurial and SVN, so SVN then Mercurial. There was another one actually that I liked better. I don't remember it now, but I used all of these at various times. And then, of course, there's the granddaddy best version control system of all time, which is ClearCase, not Git. While Git can do version control, it is an integration tool. That is why it does good merges, and that is why it is delta-based, because you want it based on deltas to do merges, right? Now, prior to this, version control wasn't designed to merge code, right? You want the human to merge the code. And there are very good reasons why you want a human to merge code and not a computer, by the way. But yeah, I'll probably save that for other videos. If you want them, comment. Otherwise, I'll probably forget and not do them anyway. The fact that you can do version control different ways, like you can use a tool like Git, Git's a super powerful tool, right? But it's a distributed code system. It's not. It's decentralized code monitoring and tracking and integration system, right? It's for decentralized code. It's not. It doesn't contrast with centralized code. All version control is a centralization of code, all of it. So that's why Git's not a version control tool as such, because it doesn't centralize the code, right? It's designed for distributed coding practices, which is a different thing entirely, right? And the reason why it's different is because in the old days, you just get up from your desk and go walk to the other person's office and have a discussion with them about how to implement something that uses their function calls, which weren't called APIs back then. We use API way too freely now. Everything is not an API. Sorry. Or you'd have a discussion. Oh, I want to use this library. You've used this library. I'll go discuss it with you. But because software companies were centrally located, right, you didn't need a distributed code tracking system like Git. Now, ClearCase had this. You could do centralized or uncentralized version control, distributed or not distributed version control, and you could mix and match all of that. It's way more powerful than anything we have today. IBM bought them somebody bought them, Perforce bought them, then IBM bought Perforce or bought ClearCase from Perforce, and pretty much it's an in-house tool, which is too bad because it's still way better than anything. You can argue the merge tool, at least the last time I used it, which was quite some time ago, to be fair, is less than optimal. But like we wrote our own merge. Like if you don't know how to write your own merge that's at least as good as Git's, maybe you're just not that kind of programmer, right? I'm not saying you're not a good programmer at what you do, but also data structures and merging. Merging is not straightforward because you need to know data structures and algorithms pretty well. And you need to understand there's a right way to store this kind of data and a wrong way. And that's really the magic of Git, which was written in about 20 minutes from the story I heard by Linus. And because the core of Git is the management of deltas, which is changes. So it's a binary tree, I think. I think it's a binary tree of deltas or something, which is the data structure behind it, which is where all the magic. All the magic's in the data structures. Everything else is irrelevant. How you store your data is super important because it constrains you. And when you ignore those constraints, which you can, you'll send 5 gigabytes of data over a REST interface like a dumb person would. So bad. And then have to, change all your Java timeouts or whatever because you're stupid and you don't know how to code. In all cases, that's what that means, by the way. There's no exceptions to that. Shouldn't have to transfer that much data. If you transfer that much data, you sure as hell shouldn't use REST. There's way better, more efficient algorithms that are quicker, or not algorithms, protocols rather, that are quicker than REST. Yeah, they're harder to code. That's why you're a bad programmer. It's not that difficult, right? And you don't understand that. Also, why you're a bad programmer. It's easy to spot bad programmers, actually. There's one way right there. But when you're dealing with data and data structures, then you can build better tools and efficient tools. And those tools will have known and understood limitations. As long as you don't try to go outside those limitations with that tool, everything is fine. Now, Git is very, very flexible. You do all kinds of things with Git. It's amazing. But it's not the world's best release tool. Knowing how to use Git, because Git can do so many things, and knowing the best way to use Git have no overlap whatsoever. Like actually none. That's the problem. So one of my specialties, we'll say 10 years ago now, but longer than that, was companies that were moving from SVN, a highly centralized source control system, over to Git. Because Git's a distributed source code control system. And while you can do distributed source control with SVN, there's a number of strategies, by the way. I'm not going to go into them here. I'm not sure I remember all of them off the top of my head anyway. And that's not what this channel's for. If you want that kind of content, go to Navigating Patterns. Although I don't talk about computers much there, so kind of out of luck on that one. When you look at the differences, it's very easy to see what misconceptions people will have when going from SVN to Git. And so I had a shop. They would be SVN guys. They had transferred to Git, 5 years ago, 3 years ago, 6 months ago, what it didn't really matter. And my goodness, they were just abusing Git in ways. And Git doesn't care. It didn't make a huge amount of difference in terms of the tool's ability to do the job that they wanted done. What it made a difference to is the quality of their software, because it just turns out that merges matter, and how you manage your source code and how you control it, that's what source code control is, right, matters to the integration, and the integration matters to whether or not your software actually works, right? So, I mean, always my specialty, or one of my specialties, is release and performance. Those are the two things I know the best. If you don't integrate your software correctly, all the code can be right and it won't run, or it won't run properly, or you'll have a weird bug. And it'll be hard to find because it's not in the code. Like the code runs in isolation perfectly. All the unit tests run. I've seen this. I've seen 100% test coverage. All the unit tests run. Software doesn't work at all in performance in the production environment at all. Does not function because integration matters. And code flow matters. And you run into this more in microservices, why people are now talking about moving away from microservices, but get this weird dichotomy now, right? Like, well, if it's not microservices, it has to be a monolith. It's like, no, it's service-oriented architecture. That's always the correct answer. Always has been for large systems. Once you reach a certain size, service-oriented architecture works great, right? You're never going to beat it. It's just not going to happen mathematically. We can model this in math. I don't know why you people are in computers and you can't model that in math. And if you can't, you shouldn't be in computers. Sorry, just reality. Maybe you're a good script kiddie. I don't know. When you're dealing with version control, your strategies matter. I prefer, it's not always appropriate for all my clients, so I don't always recommend it, right? I personally prefer stable master. In other words, all of your releases are coming off your master branch. It's that simple. I understand it's, quote, an arbitrary designation, right? Master branch or trunk versus any other kind of branch, but it's not. Like, it actually matters what you treat as, quote, canonical. Most of the shops I dealt with, especially shops coming from SVN, would use branches as releases. The problem I have with that is a little messier. And you can fix that with naming conventions and tags. Fair enough. But we often misuse those things, right? So, for example, in a release structure, you should create a branch, but you should never, ever, under any circumstances, tag a branch until it's been tested. You create the branch, you compile it, you run it through at least QA, then you tag the branch. And there's reasons why that process matters a lot. And if you don't know them right away, that's fine. Also, don't do this work. Just don't. Just do whatever you can in your space that you're good at. If it's not clear to you immediately why that's important, fair. I get it. Most people it won't be. Totally get it. Also, don't do release work, ever. You're not understanding something fundamental about a process and the difference between assuming an outcome and actually validating an outcome, right? You want things like tags to be validated outcomes, not assumed outcomes. You don't want to say, this is going to be our release. Well, why? What if it has bugs? I mean, and the industry's already doing this, right? Like, it's already happened. I didn't think it would happen, but apparently, like, who could have predicted the level of stupidity? If you're not using a release strategy, you should just push every change to production. And I've seen this. Like, this has already happened in the past, like, 15 years. People are just pushing whatever they coded straight to production with little or no testing. Unit testing doesn't count. Unit testing is extra testing that doesn't need to be done unless you're the worst programmer in the world. Sorry. You just don't need unit tests. They're not required. Unit tests were, I think I've been over this before, unit tests were originally designed for distributed coding systems in OO programming, right? When you didn't have access to the person writing the code. Nowadays, we've, quote, resolved that with APIs, which we've subsequently destroyed by making them unstable. If you have an unstable API, you don't have an API. Right? If your API ever changes, it's not an API, right? Or if it changes, we'll say, more than once every 3 years, it's not an API. It's something else. And there's a fine line between an API and a library, but libraries shouldn't change ever, right? Or almost ever. Or when they do change, the API shouldn't be affected, right? So you can fix a security bug in a library without changing the call structure, for example. That's a good example, right? So it's not an API, it's a library. It has an API, right? The API doesn't change, but the library gets updated to be more secure. Sure, absolutely. We're not doing that, by the way. I mean, it's happening maybe in limited cases. It's how it used to work. I don't know what the hell happened. The standard C library didn't change forever or much, right? They added stuff to it or whatever, right? So rate of change affects the label. You're not doing release if you're basically making 100 changes and pushing them out. 100 changes to a large source base is nothing. Basically a week's worth of work or less. what are you doing? Like if you don't want to have a release strategy and you just want to push garbage code to your clients, which almost every place I know of is doing right now, I mean, you can do that. I don't know why you need CI/CD. Like seriously, like I don't know. Like just push the code out. Like what are you doing? Just make the change and compile it and shove it on the production system. And that's what Docker allows you to do. Right? Docker enables this. There's a meme out there. Like, I was surprised when talking to people about Docker. They're like, Docker isn't works on my machine. There's literally been a meme out there. Docker is just works on my machine, taken to the client, to the customer, to the production environment. Yes, that's exactly what it is. It is exactly no different. What do you think you're going to get? You're going to get a bunch of bugs because you're not QAing your code. And you can't QA it properly, most likely. It's probably very hard to QA in a Docker environment. Regular containers like Java, you can QA that easily. Docker, no. It's really hard to QA because you'd have to check every container for all the standard bugs, right? Or you lock down your containers. The thing is, if you're locking down your containers, you should really just use VMs, really, and force your engineers to choose one of 4 VMs based on where they are in the stack. This is the advantage of a stack. The way I used to do it when I had full control, which I did a few times, which is nice. Oh, those systems never went down, by the way. That might not be a coincidence. I would have an image for the front end infrastructure, an image for the mid-tier infrastructure or infrastructures. Sometimes there were more than one, right? You'd have, mid-tier database, or you'd have, because it's not backend, or more likely you'd have mid-tier like Couchbase or something. It's like key value pair. It's high rate of change. So you need totally different system image for that if you want it to run efficiently. Performance expert, right? And then you'd have backend images, right? And sometimes more than one, right? So your backend database versus your backend data store, right? Because data store is the right way to think about these things at the end of the day, because now we have just more storage tactics, right? You've got key value pair, you got databases, you got quote blob storage, S3 buckets, things like that, right? Those are more blob storage, but you should cater them to what you need, right? So you can get crazy like I do, and you can tune the kernel settings on the network stack in Linux so that they're better for large data transfers versus very small data transfers, right? And you can make huge changes by like 1%. I think I've talked about this before. A 1% change that I made in an AWS image for a front end system resulted in a 45% AWS cost reduction. Because it's a 1% time saving on every connection, and we're dealing with 1 million connections every 5 minutes, something like 8 minutes to millions, right? Very, very large, high volume systems, banner ads. So banner ads are just off the chart. So when you're dealing with these, small 1% tunings, they have a large upstream effect because there's a lot of them. So 1% times 40 million is a significant number all of a sudden. And yeah, there's also other side effects. I think I've gone over that before. Like the performance tune of 1%, if it's the right kind of performance tune, actually has a ripple effect on all kinds of things like system load and memory and all kinds of other things, timing, right? So it reduces the time things are open, freeing up file handles. Just freeing up file handles can help you, as you know, if you've ever had to change file handle numbers. There's all kinds of downstream effects. And that's why things like Docker are poison, right? Because most systems engineers don't know how to do that. Like I'm a performance expert, and I'm a little fuzzy on some of it because, I've done it a little while, but that's hard stuff already. Most people don't even know that can be done. Like most people don't know you can tune the network in Linux for larger packet sizes and smaller packet sizes and different packet types, different data flows. And that when your system is tiered, that actually makes a lot of sense because backend systems typically deal with large chunks of data. And tuning that network makes a huge difference to a thing like a database. Huge. Right? Now, some database applications don't do that. Okay? You have to know, right? You have to do the math and figure it out and run a bunch of tests to know. But blob data, it's always big. So yeah, that's easy, right? Connection data, always small. You want to tune for very small packet sizes. You probably want to tune so that the client side drops the connection, not the server side, right? Because that drops load on the server. There's all kinds of things you can do. And some of this may or may not apply with JavaScript. It depends on how the software is written, blah, right? And it's another sin, right? We've pushed everything to the edge. So really the penalties on the client side, it's on the laptop or the desktop that the client's using or the phone, right? What do I care if it's inefficient? Right. Well, I mean, it still affects your system, right? And the less efficient your system is, the more bugs are possible. And the more bugs you'll run into simply due to timing errors. But there's lots of other ways that bugs creep into systems when they're slow. The more time you have to screw up, the more screw ups you'll have. It's a simple principle. And this is why something as basic as version control is important. It's one thing to know the git commands, or the svn commands, or the clear case commands, it doesn't matter which. It's another thing entirely to understand how to structure your version control so that your team, which is usually distributed, can be efficient. And what are they efficient in relation to? Because efficiency is not a useful word by itself. You have to define it in terms of a goal, right? Efficiency in terms of code velocity or in terms of code quality, because those two are always overlapping and at odds to some extent. You probably want code quality if you care about release. If you don't care about release, you want velocity. If you want velocity, you probably don't want a merge to trunk or master strategy, right? Because that workflow doesn't just take longer, but it has implications for how fast you can go. It's also more organized and way easier to keep track of things to do merge to master and trunk. You can get around that, again, to some extent, if you manage your branches correctly. It's not a super huge problem, but it's also a mess to look at, right? Which is a good hint that it's usually not the right way to go. But I have recommended it before, like, I don't know, use branch releases, keep your master branch completely messy because of your work style, right? Because at the end of the day, efficiency is no good if your team doesn't like it. They won't do it, right? And so you always have to cater these solutions to the teams. That's why giving somebody Git is just giving them a tool they probably don't know how to use and can't use effectively. And that used to be my specialty, saying, no, you're doing your version control wrong. Here, try this, right? Try a strategy like this. And that takes a lot of analysis, It takes me about 3 days usually to go through these things in a Fortune 500 company. But I've been doing it for years. Like, I didn't start out that way. So, right? Like, oh, now I know what questions to ask and how to ask them. 2 things, right? And then I know how to analyze the answers. 3 things, right? And that analysis is more than 3 other things, we'll say, right? But once you know that, you can give them a version control strategy that meets whatever their goals are. That means one size does not fit all. As I started out with, you can't take Git and tell people always use stable master or stable trunk. That doesn't make any sense, and it doesn't work. These things are hard because the way you structure them is more important than the way you do them. And the way you do them should be determined by their structure and not the other way around. And the industry has flipped this on its head. Not good. It's just not good. It's not good for you. It's not good for me. It's not good for software. It's not good for the industry. It's not good for all the people using cell phones or smartphones. It's not good.